it's recording.
Have you ever seen a movie where robots are capable of their own thinking? Well, we might not be that advanced yet, but we may soon be there. Hello, my name is Noah Sloat, and I will be talking about my experience with machine learning and programming robots over the last 6 months. I have been researching robotics and machine learning, as well as learning to actually program a robot to do simple tasks with only a little bit of human input. Machine learning a robot is something that takes a very long time, but I really found an interest in it, and I took the time to learn how to do it. One major part of doing anything with a robot is to actually have a robot, and for that I worked with a local robotics group to program a robot. One part of this was making sure the robot could recognize very small blocks and spheres, even a duck at one point. And to that end, I used a vision control software that aided in making a model for the robot when identifying objects. The vision consisted of 3 parts: filming, identifying, and modeling. Filming is the first and easiest part. All it is getting about 1,000 frames of an object from all different angles and light levels, and backgrounds. The camera used for this is a webcam, which is identical to the one that is actually on the robot. This part is the most important because it's used to make the model, and a model can't be created if there is without a base set of images. For other parts of the vision, there's identifying, and this part takes the longest. I have to go through and mark the object in each individual frame, which can take multiple hours. After that, I have to divide the frames up into several groups, then recombine them into a model. The models then run through a simulator, which takes a couple hours, and after that, the only thing left to do is insert it into the code. I have always been interested in teaching robots to be autonomous, and this was an exciting thing to learn about for me. Machine learning can require anywhere from very little human help to being done almost entirely by humans. This was closer to the latter end because the former takes more resources than what I had available to me at the time. The robot that I programmed is small, and is programmed with a goal in mind. It was based around one of the games from the first robotics, and so that actually helped me make a goal for the task I needed to accomplish. The goals were to have the robot be able to pick up specific objects and then place them on a structure about 2 feet tall. The robot both needed to be able to do this with human help and without human help. The robot is an 18-inch cube with an arm in the middle, and also has an intake for collecting items. One of the game pieces is even a rubber duck. I was also able to help a little bit with the construction, but since mechanical building is not my strong suit, I wasn't able to help much. The programming is still ongoing because it just takes a long time, but I'm still working on it. Some topics that I also researched were the ways that robots can teach themselves without almost any human interaction. Some ways include a method called backpropagation, also known as neural networks. This process acts to simulate human neurons, and it does it surprisingly well. Once a robot has a base model to work off of, it can teach itself new things. This allows them to have the ability to learn new things, but these things must be similar to the base model, otherwise a new model must be made for each concept. Additionally, robots can't think very abstractly since everything they do is mathematically based. Despite this, it is still currently one of the most popular ways of programming AI. How it works is that there's a series of layered nodes, and the nodes simulate the neurons in a human brain. Each neuron comes with a number between 0 and 1, which shows its dependence on that particular type of rule. A 1 will mean the robot always follows the rule, and a 0 means that it will always ignore it. Each time a robot sees an example of its base, the nodes are all updated in accordance with the rules, and if it gets the output wrong, it goes back through and redoes all of the nodes, tweaking their values slightly, unless it is very early on in the process, in which case these values are greatly changed. This continues every time the robot gets a new example. One of my favorite examples of this is a chess bot that ended up beating a grandmaster by learning how to play and then teaching itself advanced strategies. And chess is not the only activity where the AI has learned to beat a grandmaster, which is really testament to how robust these systems can be. I first got interested in AI learning from playing games, as well as from movies such as Star Wars. It has always been a passion of mine, so that is a big part of the reason I went with this for my senior project. I've always been one for new types of technology, and the thought of robots has always been one that I was most interested in. I also went with this because I've always wanted to get hands-on experience with coding. The Programming the robot is something that I plan on continuing over the next couple of weeks to finish it. I really enjoyed this experience so far, and I believe that robotics is something that is not nearly as complicated as everyone makes it out to be. In the end, robotics is something that could very well become the future of humanity and how we do our daily lives, and I would love to be a part of that.
Awesome. Does anyone have any questions for Noah?
Where do you want the robotics? Is it the robotics team here at school?
No, it's not the one here at school. It's actually a local group over in Dumbarton.
Awesome. And are you still part of that?
Yeah.
Is it ongoing now?
Yeah, it's ongoing over the next couple of weeks to finish it up.
Awesome. Nice job.
Awesome job. Thanks, Noah. Well done.
Alright, so now I get to take all this stuff off. Really not that complicated. No, it's not.
Oops, I gotta stop this.
Yeah.